Hi everyone, in this video we'll go through differentiation of infinite series. That is, given infinite series functions, how do we arrive at derivatives? So what do you mean by infinite series? So we have a function, say for example, y is equal to x to the power x, right? Now here if you see it's going till infinite, right? X to the power x, to the power x, to the power x, to the power x. So it keeps on going and it's infinite. There is no end to this. So this kind of function is called as infinite series function. Similarly, here if you see, we have y is equal to square root of log x plus square root of log x plus square root of log x till infinity, right? Now, how do we find the derivative of such functions? So what we will do is, from this entire infinite series, say we'll take this example, right? We'll take the first term out. What is the first term? It's square root of tan x, right? We'll take first term out, which is square root of tan x. Then plus this repeats itself again. Square root of tan x repeats itself. So if you notice, this is also y itself, right? This also is y, right? Root of tan x plus till infinity is y. So we'll substitute y here. So now what do? We'll have to eliminate this square root. So we can apply square on both sides, right? You can take square on both sides. Apply square on both sides, so that we remove square root. So it's going to become y square is equal to root of tan x plus y the whole square. Square root and square will get cancelled. We'll get y square is equal to tan x plus y. Now we'll differentiate. Now differentiate with respect to x. So we'll get, what is derivative of y square? Y square is 2y into, we'll have to put dy by dx. Because we have y, we'll have to always put dy by dx, which is equal to tan x plus y. What is derivative of tan x? Secant square x. And what is derivative of y? It's 1 into dy by dx. We'll always have to put dy by dx. So now let's get all dy by dx to one side. So when I get this side, this is going to become minus dy by dx is equal to secant square x. This is nothing but, I take dy by dx as common. We'll get 2y minus 1 is equal to secant square x. Now I'll have to just find dy by dx. Dy by dx, let me shift this here. So it will become secant square x by 2y minus 1. So this is what we are supposed to prove here. Secant square x by 2y minus 1. So dy by dx is secant square x by 2y minus 1. Hence proved. Now let's take another example. If y is equal to e to the power x, to the power e to the power x, to the power e to the power x till infinite series, we have to prove that dy by dx is y square by 1 minus xy. Now what do? We'll take first term out, right? We take first term out. That is, first term is e to the power x, right? E to the power x. To the power. Now what is this? If you notice, what is this? This is nothing but y, right? This is nothing but y. So I'll write y. E to the power x to the power y. Now I'll apply log. Y log, because there is power here. Apply log on both sides. Apply log on both sides so that I can get rid of this power. Because there is a logarithmic property, log m to the power n is n log m. So this is going to become log y is equal to log e to the power x to the power y. Now this is of this form, m to the power n form, right? So I can bring this to this side. So it will become y into log e to the power x. Now again, there is power here also, right? Again, I can use the same property and bring x this side. So it will become x into y into log e, right? Using the logarithmic property. Now log e is 1, right? Remember always log e is 1, right? So this is equivalent to log y is equal to xy into 1, which is xy. So what do I get? I get log y is equal to xy. Now I have to differentiate with respect to x. So what do I get when I differentiate? What is derivative of log y? It's 1 by y into dy by dx. Because we have y, we'll have to put dy by dx. Now here we'll have to use product rule, right? We'll have to use product rule. What does product rule say? First term into derivative of second term plus second term into derivative of first term. This is nothing but first term is x into derivative of second term, that is y, which is 1, into dy by dx, plus second term is y into derivative of first term, that is this one, x. So this is first, this is second. So what is derivative of x? 1. So we get x into dy by dx plus y is 1 by y into dy by dx. Now let's bring all dy by dx to one side and we'll simplify it. So we'll get 1 by y dy by dx minus x into dy by dx is equal to y. Now let's take common here, right? We'll take dy by dx as common. So I will get dy by dx, if I take as common, I'll get 1 by y minus x, and this is equal to y. So now I'll shift this here so that I get only dy by dx. dy by dx is equal to y. This is going to become divided by 1 by y minus x, right? Now I'll take the LCM. What is the LCM? Y is the LCM, right? 1 minus, this has to go y times. 1 into y is y. So, but I have to multiply the numerator. I have to multiply the numerator with y. So, I'll get 1 minus xy, right? Now, I'll shift this up. When I shift this up, it's going to become a reciprocal. So, I'll get dy by dx is equal to y square, because y into y will be y square, by 1 minus xy. So, this is what we are supposed to prove, right? Y square by 1 minus xy. Y square by 1 minus. So, we have proved this. With this, we've come to the end of this particular topic. If you have liked this video, do press a like and share it. Thank you.